Yeah, so welcome to this course, Introduction to Data Science. So we're going to start the beginning that we want to give you some introduction, some basic idea about what is data science. So we talk about several events, historical event has been historical events, and also we talk about some keywords, some buzz terms like people heard a lot, okay, such as artificial intelligence, and also move on to talk about several algorithms, okay. So what is the AlphaGo, right? So I think AlphaGo, most of you has been known this story, right? So the story is like, the once upon a time is actually the year is 2016. So now is already more than just like 5 years ago, right? So at that time, there's a huge event. There's a contest between, there's a match between AlphaGo, which is a program designed by some experts, some AI experts, and also uh, on the right hand side that we see uh, the the master that he can play a Go game. A Go game, by the way, that if you know that Go game is like on the right hand side, as you can see the board that we have black and white playing two sides, right? So to one try to conquer as much space as possible. By that goal, then they can win the game. Okay, so on the right that we see the Lee Seido. Actually, he's a Korean master and he can play the Go game quite well. So that's why they designed such a match. Okay, this uh, seven matches, and which one then they can win 4 out of 7, they can win the game. Okay, so you know the history, right? So it's in the end. Okay, so we know that Lee Sedol lost to the AlphaGo, right? So it's like 1-4. Okay, Listo at least he can win one game, right? So before that, some may know that the AlphaGo is like some weaker form of AlphaGo. Uh, it can play with the European Championship and got like 5-0, right? So the AlphaGo won all 5 games. Okay, so maybe on the right, on the left, you see the championship is Fan Hui, right? The European Championship is Fan Hui. It's like like a half year before the 2016, right? So that everybody focus, pay attention to that 2016 contest, right? But half year before that, then we know this event 5-0, right? AlphaGo uh, beat the European champion Fan Hui for 5 times. Okay, so maybe you see the middle. There's one guy, actually that's an editor uh, from Nature, and actually he is like checking that the match. There's a real computer system or maybe computer software that software can really play the Go game. So that's why after the contest, right? So they publish a paper, or maybe around the same time they publish a paper to Nature to describe what's going on. So probably you also know that around like 1 year later, right? So the AlphaGo also uh, have another contest with Ke from China and got a 3-0, right? So the AlphaGo also won again for 3 consecutive times, right? So all this just give us the historical event, one of the phenomena, like okay, the computer can actually do something that the human can do, right? So that's why we usually say this belongs to artificial intelligence, right? So as you can see that data science and artificial intelligence is quite related. So we are going to discuss this comparison or maybe from different viewpoints right away. Yeah, so actually there's another contest that belongs to chess, right? The Western chess, right? So actually it's 1997 where I was a PhD student and there's a IBM design uh, program called Deep Blue. So on the left that you see that, right? So uh, that software can play chess, right? And actually won um, the contest over there's a famous master, also the chess master from Russia. Okay, so what is different between now and then from 1997 to 2016 is that before now, like 1997, right? So I mean, both cases, right? The computer program can win the game, right? But what is different is that back to 1997, right? So the program just use a very simple algorithm, a very simple algorithm that called alpha beta pruning, right? Maybe you know it, maybe you don't. That's okay, right? But to 2016, right? So they already designed a very complicated uh, a program called that a lot of a huge part belongs to so-called now it's very famous deep learning method, right? And plus something else. Okay, so what we want to emphasize is that now that AlphaGo or maybe after the like 2016, right? So we can deal with the situation much with much higher complexity than before, right? And also probably you also know that now that the program use some kind of algorithm that we can usually say is more like a general purpose. So why it's like general purpose? Just because this algorithm will not just do one thing but multiple things, right? Maybe with different settings or maybe with different parameters, but at least that you don't have to write different program, right? So maybe you can write a single program but just let the program play with some other that we say training, right? The training is something that okay we can really emphasize a lot in this course. So what is training? So what is training? So maybe you can say that. So we talk about training, right? We talk about training. Okay, we could talk about training. So the training is actually based on what? Data, right? Based on data. So given data after the training process, so we are going to build a model, right? So model is the code that we just talk about, the software we just talk about, and in fact that the code, the software can give us very strong power like AlphaGo. Okay, so so as you can see that so that's why in this course we focus on data just because given a lot of data we can make sure that the model will be smarter and smarter as we do the training after a few iterations. Okay, yeah. So that's why we say it's like a general purpose algorithm. General means that given different kinds of data, we're going to see maybe very different result. Okay, and it's not. And also, we want to emphasize that given such a modern program, it's not just based on handcraft rules, right? So, as you can imagine, that before now, when we want to design a program, uh, which can play chess or play some kind of maybe like Go games, right? So usually we uh, handwritten, hand like use some experts to help us to summarize what could be the way to win the game, right? So we make them to be rules, okay? So that later, okay, the code, the program we may have a good performance, right? But it turns out that this kind of rules is not really, let's say, belongs to computer, right? In a sense that we can say is from human experts, right? So that's why if we don't give clever enough rules, right? So the code may not look like clever, right? May not be smart enough to beat humans, right? So even that, the rules will be very super smart, right? But it still belongs to experts, right? But not anymore, right? Now, like we have, maybe we can imagine more likely that we can see uh, there's a intelligent built-in in AlphaGo, right? Just because that uh, now the AlphaGo got a model, got a code, that got a program that's not 100% designed by experts, right? It's more like we use data to give us that kind of possibility, right? So the data really, one more time that we have to emphasize, there's a data make everything to be possible, right? So that's why we say maybe we can imagine, AlphaGo has intelligence or some other machine learning or maybe AI model got some intelligence, right? So and on the other hand, we also say, oh, it's like the program can think, right? So what that means is that actually we see the training, right? We see the training actually is not just done by a few seconds, right? Usually it's finished in a few iterations. So that's why we feels like machine is also thinking something. After the thinking, then they can get a good result, right? So they can get a good model, right? So that's why we feel like the code, the program can also think like human. So we talk about, okay, make everything to be possible. It's just because we have the data, right? So what kind of data that we have? So we all heard about big data, right? So just give you some idea, right? So maybe in many years up to now, right? So we can collect a lot of data, right? So in some old statistics, right? Maybe not today, right? So every day they can get like 2.5 quintillion data, bytes of data, right? And also, as you can see that 90% of the data actually generated per day today, right? It's like actually, you know, uh, 90% of the data that we got now belongs to last few years. Okay, last few years, right? So it's not too surprised that to make you agree with this statement, right? Just because that in the modern days, right? So we do have a lot of different devices, right, to help us collect data, right? Such as that we can use a camera, we can use like building devices in smart factories, or maybe we can try to monitor traffic, right? Or maybe weather, right? So all kinds of things, right? Continuously give us more and more data, right? So on the other hand, we also have something we call the devices, right? Quite not quite like devices, but more like some that kind of a program or maybe a server doing things like monitoring humans' activities, right? Such as, we use a smartphone, right? So we use Facebook or all kinds of social networks a lot, right? So all this also uh, can collect a lot of data, right? So I don't need to give you exact number, right? So maybe we can take a look, right? So what kind of number that we say, oh, the big data is big data, right? So 1 petabyte, right? Well, now we talk petabyte rather than terabyte, right? Or gigabyte, right? So usually in this community, if we say something belongs to big data, right? If we want to publish something, right? Big data usually, if not too embarrassing, that usually we talk about terabyte, right? Sometimes gigabyte can also give us some valuable information, but it's hard to say that it's really considered to be big data, right? But later we're going to say volume is not the only thing that we care about. Why we say it's big data, right? Okay, then we also have petabyte, right? We also have petabyte, and petabyte, 1 petabyte is what, like 13 years of HDTV, right? So it's like a lot of movies that you can never finish, right? And also, what we want to emphasize is like 50 petabyte is actually the entire written work from mankind, right? So as you can see that think like this, right? The hard drive and everything, right? The storage, it will be good enough to store all the things that we have written before, right? So even though that the next thing to ask is that can we get at some kind of clever enough model maybe, right? Or some kind of mechanism to read all this valuable data, right? So that's something that we have to pay attention to, right? So then given the big data, we talk about different V's, right? So usually that people focus on volume, right? Velocity and the variety and also veracity, right? So all belong to different viewpoints. Okay, like why that we talk about big data, this new term these days, right? The volume, of course, that we know that, right? So the data is quite a lot. So many data, right? Usually we need a huge storage, right? And these days, right? Maybe you heard about federated learning. Federated learning. Let me just write it down here. Okay, so federated learning. Federated learning. Federated learning is actually assumed that the data collected in different locations, right? So and locally, then they can build data based on the local data, and then we want to collect each of the local model, right? We use the local data to train the local model. Then after we get a lot of local models, we want to say, can we get a lot smarter a model than all the local models, right? So that's also related to volume because the data is so big, right? Usually it's not wise to move data around to different places, right? So then we can say, oh, it's just too big to bring data around. Then why not just to train the local data, right, in local area? After that, we try to unify, try to integrate all the knowledges collected by different local area together to see if we can get a global view, right? Okay, so velocity means that simply means that the data usually generated very fast, right? So even that maybe you got tons of storage, right? So you still need to make sure that your model is uh, effective, maybe can deal with the data very efficiently. Okay, very efficiently means that every 1 second, every few seconds, right? So how much data the model can process. Okay, maybe the first step is that to make sure that the data stored somewhere, maybe transmit through internet. Okay, up to some local server, whatever, right? So you need to make sure that all the hardware plus software can really deal with very fast generated data, right? So that's kind of challenge that we always have. Okay, especially these few days, right? These few years. So variety means that okay, in the old days, right? So in the the prior the sharing, the video streaming, that you probably also see that, in the old days, right? So most of the experts, right, like a data scientist, right, like a statistician, right, they deal with numerical data most of the time, right? Not anymore, right? So we have images, we have video, we have speech data, right? We have all kinds of things, right? Even like text from social networks, right? So as you can see that the second half of this course belongs to social networks, right? Then the variety play a role here, right? Just because we have all kinds of data, right? So the model that can deal with numerical data doesn't mean that they can also deal with video data or languages or maybe text or all kinds of data, right? So it could be very different discipline. Okay, so veracity means that these days, right? Just because we have a lot of data collected by devices, right? But it doesn't mean that many of the data will be very accurate, right? Most of the time, right? We can see noisy data here and there, right? So it's up to our data scientist or maybe data engineer, right, to clean the data first before we can say usually garbage in, garbage out, right? So we need to make sure that the input, the data will be somehow valuable to do further analysis. Okay, so then now we are going to say the data changes the games, right? Why we say that? Just because we have an old day, right? It's up to some expert to help to say, oh, so which one, what kind of model should be a good model, right? So not anymore, right? So we're going to say now the model is not quite up to a small set of experts, right? It's more like we build a model based on tons and tons of data, right? So these days that we maybe rely on deep learning to give us the answer, right? So data is king, right? So usually we say that some big companies, right, like Facebook, like Google, and Twitter, right? So they got a lot of data, so that's why they know like many things like we don't know, right? So someone that got a lot of data, maybe they can tell different conclusion, right? Some kind of conclusion may get business here and there, right? So we need to make sure that if we are not belong to the big data, big company, right? So how can we survive, right, in this modern world, right? Okay, so then the next thing to say, okay, given such like a big data era, right? So what kind of techniques that we need? So basically, that's what we need to learn for this course. Okay, yep. So let's move on. Okay,